Hello everyone, my name is Rahul. In this presentation, I will be explaining topological sorting. We will explore how to use DFS to find a topological sort of a directed acyclic graph, and we will even see a simple example. Let us start. First, let us know what is meant by topological sorting. It is a linear ordering of graph vertices such that after every directed edge UV from vertex U to V, U comes before V in the ordering. It is applicable only on DAG, that is direct acyclic graph. Linear running complexity. The running complexity of this is linear. Like if it traverses five elements, then the time complexity is five. And it is only applicable on acyclic graphs, not on the cyclic graphs as shown in this. This is a cyclic graph. It completes the cycle. So we cannot prepare a topological sorting method for this. And the solution can be unique also. Now let us see in the next example how the solutions will be unique. As I said earlier, the solutions will be unique. See, now you can travel either from B or from A. If we start traveling from B, we'll get the solution as B to A, then A to D, then D to C. So it will be topological order will be B, A, D, and C. Now, if we travel from A, then it will be A, D, C. Then before that, B is existing. So A, D, C, then we'll add B before that. Because when it is said that the previous element, that is U, will come before B. The direction of this graph is U to V. So it will be B appears before A. Now, when we check this, see, suppose C is existing after B. So in this, we can see that C comes after B. So B is prior to C. Now let us see an example how it works. So there are two graphs in this connected to each other. So we'll get two different solutions and then combining them together. So in this, we can travel from two positions, B and G. Now let us start traveling from B. Then after from B, we can see that A is connected to it. Then we get A, then it is directed towards D. Finally, it is directed towards E and C, both of the elements. Now let us go to C first. Now C is the dead end. So when we reach the dead end, the element gets added into stack. So the C element gets removed and it gets added into stack. Now then we'll check if any other element can be traversed from D. There is an element which we can travel from the position D. That is E. Now let us go to E. Then E is the dead end. We cannot reach any other element. See the direction of F, it is in the opposite direction. So we cannot travel to F position. So then E gets removed and it gets added into stack. Again, there is nothing left. We can travel from D. So D also gets removed and it gets added to stack. Similarly, it happens with A and B, both of them. Now the next element, it is G. We have to travel from G. Now we have already visited these elements. B is visited, A is visited, C, D, and E. Now we are left with G, H, F. So let us start. Now after G, it is directed to D and F. Since D is already visited, we won't visit the D element. Instead, we will go for F. Now the F element is reached and it is the dead end. We cannot go for further any connections because E is already visited and there is nothing other element which is connected to F. So F gets removed and it gets added to the stack. Then G also it is completely visited every element. So G also gets removed and it gets added to graph stack. Now the only left out element is H. So now let us visit H element. So all the elements are visited. Nothing is left in the DFS to visit. So H also gets removed and it gets added into graph. Now you can see that all these elements are visited and it is added into stack. Now to write the topological order, we have to remove this element from the stack by using first in, first out, last in, first out method, and we will get the complete topological order. So this is not the only solution which we can find from this. We can even find multiple solutions for this. So it depends from which element we are started. Now we started from B, then we visited to G after completing the B graph. So we'll get this kind of solution. If we start from A, we'll get a different solution. If we start from G, we'll get a different solution. If we start from H, we'll get a different solution. But still, all the answers are correct. Now, as you can see, all these elements are arranged in topological order. Like we can compare and check whether all these are connected properly or not. B is directed towards D. That is, D should appear after the existing of B. Here you can see B is prior to the D. So this is correct. And let us check one more case. Suppose we check for G and F. F should come after G. Here in the topological order, you can see that F appears after G. Also, let us see D and H. D comes before H. See, you can see the graph. After B, D comes, then E, then H is at last. So H appears before D when you traverse back like this. So it is also true. H appears before D. Then let us check for G and A. Here also you can see that enters first, then A. So A is appearing after the existing of G. I hope everyone understood topological sorting using DFS method and even understood the example which I have explained in this video. Please like this video and subscribe to my channel. Thanks for watching.